Hi, my name is Avelyn, and this is my project, CookieGuard AI. Cookies are information files that let websites remember and identify users. Session cookies include authentication cookies that function as part of our digital identity credentials. Every day, while we encounter tens of websites that ask us to accept their cookies, many of us don't actually understand the security risks that can come from this. Unfortunately, a report by NordVPN explains in 2025, 94 billion cookies, including 1.2 billion directly related to user identity, were stolen and published on the dark web. Cookie-based identity theft is hard to see because login cookies act like hidden credentials. However, if attackers steal them, they can impersonate users without even needing a password. These identity-threatening attacks happen with misconfigured session cookies that have your identity credentials, with three main risks, being token exposure, cross-site execution, and domain scope. However, existing tools fail to identify which cookies are actually identity critical and whether they are at risks. This is what my project CookieGuard AI focuses on, finding and classifying these identity critical cookies and alerting the users because of these risks. The development of CookieGuard AI began as a three-component pipeline consisting of a cookie downloader, a back-end model, and a front-end visualization interface. The downloader extracted cookie metadata and exported as structured JSON files. Then, the back end analyzed these features using a random forest classifier, and then the front end displayed analytical results with explanations to the user. However, while I was working on this, I realized one big challenge. Exporting cookies as data files introduced some pretty large privacy concerns, since stored and sensitive metadata could be potentially replayed or mishandled across servers by the user. Additionally, maintaining a separate front end created difficulties for non-technical users to use. So, to address this challenge, I redesigned the system to the pipeline you see on the screen now. It runs as a Chrome extension that performs runtime cookie metadata extraction directly within the browser, integrated with the user interface. This eliminated the risk of exposing and exporting sensitive user information while making it easier to use the tool in general. Now, CookieGuard AI intakes this metadata, extracts its features, uses the model to classify which are the most identity critical, prioritizes it, and alerts the users based on the risks. Now I'm going to demonstrate the actual model and extension. First, all of the code in the project is in this repository here. In order to actually run and get the extension working, first you need to run the back end. There's instructions, simple instructions here that will help you run it. And as you can see, I have mine running already, so I can use it as an extension with the model. In order to actually have the extension into your browser, you can load the unpacked folder here. The folder is simply just this CookieGuard plugin folder, and once you load it in, it should show up. If you go to a website that you want to use, you can just click on the extension, which will you'll see the back end is connected if you're running it, and go ahead and scan the cookies. Then it will give you critical, high, medium, and low of authentication cookies it finds on the website and alerts you for anything you need to see. For example, it gave me a medium level alert for this specific cookie. This one is also tagged as review, which means that the model is slightly unsure and the user should actually review it to see whether it's true or not. As we can see, its confidence is around 65%, which makes this reasonable. If I click in, I can find out more information about the cookie here. I can find out about parts of why the model flagged it this way and the risk formula, and finally at the bottom some recommendations for what to do if I have this cookie. If I notice that it isn't actually a threat, I can also choose to simply ignore it. For example, if we go to another website that is safe, we can see it won't give us any alerts. In order to learn more about the model, we can click how the risk is calculated here to see the multiple models we tested before deciding on the random forest and the feature groups and the risk formula.